And reading number 1 here, we have Brian's hockey team is purchasing jerseys. The company charges $250 for a one-time setup fee and $23 for each printed jersey. Which expression represents the total cost of X number of jerseys for the team? So a couple key words that they gave us is a one-time startup fee or setup fee, and then the $23 is for each printed jersey. So anyone want to eliminate one of these cases? Yep, because we have to take into account the $250. And here we should be thinking y equals mx plus b. Remember, b is always our starting amount. So our setup fee, that $250, is our startup amount. So the best answer here is going to be choice 3. Where if they sell 2 jerseys, they would take $23 times 2, being x, plus the startup fee, and so on. Okay. Moving down to number 2. Which table represents a function? Now, we've reviewed functions a couple times in the last few mixed reviews. Does anyone want to tell us what should not repeat? Thank you, Lizzie. X values should not repeat. And that's just a little clue when you're looking at these tables. That's not going to be our explanation for some of these questions. So what choice is it going to be so that the X values do not repeat?
4.
Choice 4. Oh, and do you guys agree? Jaden?
Yes.
Yeah. So -2, 0, 2, and 4 don't repeat. Number 1, every input as a 1 here is mapped to a different output. That's bad. So number 4 is a great answer. Moving down to number 3. Which expression is equivalent to 2 parentheses x squared minus 1 plus 3x parentheses x minus 4? Now with this case, if we had our graphing calculators, we could try to y1 this and then test each choice into y2. But we do know how to distribute and combine like terms. So I'm going to rewrite this. 2 parentheses x squared minus 1 equals, plus, my mistake, plus 3x parentheses x minus 4. When we distribute, who can read me the next equation? Maybe Jaden or Owen? We've heard from Lizzie.
I'll read it.
Thank you, Owen.
Which expression is equivalent to 2 parentheses x squared minus 1 plus 3x parentheses x minus 4.
Okay, so if we distribute the 2 here, what do we get first?
An x and a times, I don't know.
So 2,
whatever you call it. I'm starting to lose my math skills.
That's why we're doing these, right? We appreciate you guys showing up. So here, when we distribute 2 into x squared, we get 2x squared. And then we're going to distribute 2 times -1 is -2. Can you guys hear me okay? I'm hearing a little bit of back talk, right?
Yeah, that's from Jaden.
Oh, is it? Here, if we distribute 3x to x, we're going to have 3x squared. And 3x to -4 is going to be -12x.
Jaden, it's actually coming from you. What's going on?
Oops.
You know what's going on there?
Is he able to mute it, maybe? Or it's echoing? Maybe he fell asleep.
No, I didn't.
Oh, okay. So when we combine like terms, Jaden, what do we get? We have 2x squareds and 3x squareds are going to make
6x.
So here we're adding. So we're just going to have 5x squareds. And then can this -2 combine with the -12x? No. So we're going to have -12x be our next term and a -2 at the end. I think I kind of wrote through our answer here. Best answer is going to be choice 4. Moving up to number 4. Number 4 says the value of x that satisfies the equation 4/3 equals x plus 10/15 is. Stopkins, I can't see who else is here. Do you want to have somebody explain what to do?
Jaden. Let's see. Oh, Chloe's here. Hi, Chloe.
Good morning.
All right, so Lizzie, what do we do when we do these types of problems? How do we solve them?
By cross multiplying.
Good, cross multiply. And what do you have to remember to do, Jaden, with that x plus 10 when you're cross multiplying?
Good question.
So yeah, see what Mrs. Locke just did. You have to make sure you put it in parentheses. So we got to make it into an equation. Don't cut that.
So 3 times x plus 10 equals 4 times 15. We're going to distribute that 3 to x and 10. So we get 3x plus 30 equals 4 times 15 is going to give us 60. And continuing our solving, we're going to subtract 30 from both sides. Anyone want to tell me what the next line will say? 3x equals 30. And dividing by 3 on both sides, we get x to be 10. Okay, which will give us choice 3. So again, the key piece there was that we need to use those parentheses around that x plus 10. Now, this being multiple choice, sometimes you could have used the strategy to substitute each choice in for x to see what gives you equal fractions. But solving is always the preferred method for these questions. Okay. Number 5. Which type of function is shown in the graph below? So here we have the y-axis being population and the x-axis being time. So as time goes on, the population goes up pretty fast. What type of function is that? Choice 1, linear. Choice 2, exponential. Square root or absolute value. Yeah, I heard a couple of you say exponential. Remember, linear functions look like a straight line. Square root functions, remember, curve, kind of like a swoop up and around. Absolute value functions, what shape do those look like? A V shape. Okay, so it was exponential, where it kind of swoops up. And what's growing exponentially right now? In real life, outside our doors. I think an exponential equation has shown up on every test question. Looking at number 6.
Curve they're talking about is the exponential curve we're trying to flatten.
Right. So our curve right now for this coronavirus is theoretically going up and coming down in a way. We want it, that's the number of cases, we want it to kind of flatten out. So we have enough hospital beds to handle everybody who's falling ill. So looking at number 6. Oh, I'll forget that for now. A child is playing outside. The graph below shows the child's distance in yards from home over a period of time t. So that the wording is pretty important. It's showing the child's distance from home over a period of time t. So at the start, the child is 10 yards away from home, okay? What happens along that line up to 2 seconds of time passing? Can anyone explain what's happening from here to here on the graph?
It's decreasing.
Yeah, the distance from home is decreasing. So what does that mean the child's doing? Like, think about yourself in the backyard. If you're 10 yards from home at the start, and now this ordered pair says 2 seconds later you're 4 yards from home, what did you do?
Moving closer.
Yeah, you moved closer to home, right? And that's what the question's asking about. So really, notice what I did there. I read the question, and then I tried to understand the context of the graph. I said, oh, at the start, they're at 10 yards away. 2 seconds later, they're 4 yards away. Then it kind of jumps. They get farther and closer, okay? Then they run away from home for a few yards, and then kind of stay where they're at. So that's where it's going to be important to try to understand the context of the picture in order to answer these questions. So which interval represents a child constantly moving closer to home? That's going to be from 0 seconds to 2 seconds. So that's going to correlate with choice 1. Did you have a question, Owen?
No, I was just saying what the answer was.
Oh, yes. All right. And number 7 actually correlates to what we were just doing in unit number 7. Was area and perimeter of our shapes. So here, the length of a rectangular patio is 7 feet more than its width, W. So labeling a picture for a second here, what could I put on either side, rather the length or the width? What do we know? The width is W. And the length, the longer side, is 7 feet more than that. So how do we represent that? W plus 7. Okay, so continuing the question, the area of the patio, so area of a rectangle is what they're asking for, can be represented by which function? So area formula for a rectangular patio, does anybody remember the formula?
AW. Wait, no.
Close. A equals,
Length times width. We also had the other one, perimeter equals twice the length plus twice the width, but we're not using that one right now. So if that's what was coming to your head by any chance, that's perimeter. That's the distance around. Here we want to just find the area. So the length we represented by W plus 7, and the width we represented as W. Now, does that look like one of the 4 choices there? W plus 7 in parentheses, because it's a binomial, so we use parentheses. Sorry about that. Let's grab the marker back. Times W? No, not yet. So what do we have to do when these two things are listed next to each other?
Solve them.
Well, not solve them, but combine them. So here we're going to distribute that W in. So W times W will give you W squared, and W times 7 is 7W. So the best answer here is going to be choice 2. Moving down to the last question, number 8. If g of x equals negative 4x squared minus 3x plus 2, determine g of negative 2. Okay. So this function reads, pick out a fun color here. G of x equals negative 4 times a number squared minus 3 times a number plus 2. So remember, x here is some number that we need to be told. Now in this question, they ask us to find g of negative 2. So g of negative 2, we're going to be putting in negative 2 for the x's. Squared, minus 3, Miss Locke, times negative 2 plus 2. Okay. Now, if we had a nice, beautiful graphing calculator, we could type that in, or we would use our y equals button, but we're kind of limited here today. So what I'm going to do is help you kind of do this out in our heads. Remember, we need to follow our PEMDAS rules. So those of you who tend to try to do this, again, using mental math, we forget about exponents. So we have to do those exponents here first. So we're going to keep -4, and -2 squared is actually +4. -2 times -2. Then we have -3 times -2 plus 2. So once we've done our exponents, we're going to go and multiply. So here, the first product that we have is -16, -4 times 4. Then we have the product of -3 times -2 is +6 plus 2. And here we have to add and subtract. Sorry, I'm trying to get rid of that little box there. It's not working. We add or subtract from left to right. So -16 plus 6 is -10. Add 2 more gives us an answer of -8. So g of -2 is a solution, y value of -8 is our final answer. So again, we inputted -2 and we got out -8. So I think that's it for the questions today, Ms. Jobkins. And we're planning to post mid-review number 6 tomorrow.
Yes, that'll be our second assignment for this week. So all of you guys, I don't think were on when we were talking earlier about what's the plan after this week. So you all probably, if you checked your email, you should have received an email from us that said there's an optional work packet. So you can either print out the work or you can go to school tomorrow and pick it up. So it's from 7:30 a.m. to 6:30 p.m. The piles are going to be divided up according to teacher, and you can just pick it up in and out. I think they're going to be outside, so you don't even have to go in the building.
And again, that's optional. The other option is to handwrite out notes onto just loose leaf paper. Or again, if you have somebody at home that can print it for you, that's also an option if you couldn't make it tomorrow.
So we'll do what we did last time. If you guys can hold up your work to the screen and to show us that you did it, we'll give you